Good evening, everybody. This is Carolyn, Kilo 6 Charlie Oscar Bravo, and I've got a presentation for you. I have to preface this by saying that I am by no means a scientist or a solar storm expert, and so don't ask me any scientific questions. I only know what I managed to gather from putting together this presentation, but I think it's timely and would make a good discussion.
Have you ever wondered what happens when the sun throws a tantrum? As we navigate through solar cycle 25, which began in 2019 and is expected to continue until around 2030, we're entering a critical phase. This cycle features escalating solar activity, including solar flares, coronal mass ejections, and solar storms expected to peak this year or next. In this video, we will delve into the recent surge in solar activity, discuss the significant impacts these solar events can have on our planet, and explore advanced strategies to protect our technology and natural ecosystems from the sun's explosive temper. In recent weeks, we've observed a record-high sunspot count, the highest in over 2 decades, with a single day seeing up to 9 major solar flares. This level of activity marks a significant uptick as solar cycle 25 escalates toward its peak, anticipated to be higher and sooner than previous forecasts had suggested. Sunspots, the dark patches on the sun's surface, are cooler areas caused by disruptions in the sun's magnetic field. These spots are often the precursors to solar flares, explosive releases of energy that can send billions of tons of coronal material hurtling into space. The science behind these phenomena is rooted in the sun's magnetic fields, which twist and tangle over an 11-year cycle. As these fields snap back into new positions, they release immense energy that we observe as solar flares and coronal mass ejections, CMEs. The effects of these solar flares are not just spectacular to watch, but can have tangible impacts on Earth. High-energy photons from these flares can ionize Earth's atmosphere, disrupting the transmission of radio waves and degrading signals from GPS satellites. This can lead to interruptions in communication and navigation technologies that are crucial to many modern-day activities, from aviation to mobile phone operations. The term solar maximum refers to the period during the solar cycle when the sun's magnetic activity is at its height. It's during these times that we see the most intense and frequent solar flares and CMEs. This heightened activity can lead to more severe geomagnetic storms, which, in turn, can affect electrical grids and communication networks on Earth. The last severe geomagnetic storm, a result of such solar activity, led to spectacular auroras far from the poles and highlighted the disruptive potential of solar events. When coronal mass ejections, enormous clouds of magnetized plasma from the sun, hit Earth's magnetic field, they can induce powerful geomagnetic storms. The most severe of these can disrupt power grids by inducing currents that overload electrical infrastructure. A historical example is the 1989 Quebec blackout, where a geomagnetic storm left millions without power for hours. Today, with our even more interconnected and electricity-dependent society, the stakes are higher than ever. The economic implications of a major solar storm are vast. It's estimated that a single severe geomagnetic storm could result in economic losses of tens of billions of dollars globally. These losses stem from damaged power grids, disrupted satellite operations, and the cascading effects on everything from emergency services to financial markets. Moreover, the recovery from such widespread technological disruption could take weeks or even months, compounding the initial economic impact. Apart from technological disruptions, geomagnetic storms may also influence animal behavior. Animals that rely on geomagnetic cues for navigation, such as migratory birds, bees, and sea turtles, might display unusual behavior during these times. For instance, there could be disruptions in migration patterns or even daily travel routes as these animals attempt to recalibrate their internal compasses to the shifting geomagnetic fields. These behavioral changes are crucial indicators of the storm's impact on the natural world and can have cascading effects on ecological systems. Advancements in space technology, particularly with satellites like NOAA's GOES series, have significantly enhanced our ability to monitor and predict solar activity. These satellites are equipped with sensitive instruments capable of detecting even the slightest changes in solar energy output, which provides real-time alerts for solar flares and CMEs. As we approach the peak of solar cycle 25, it's important to understand the levels of the geomagnetic storms, as current observations and models suggest that solar cycle 25 could be one of the most active in decades. The NOAA space weather scales classify these storms into different levels, ranging from G1, minor, to G5, extreme. Each level corresponds to potential effects, such as disruptions to power grids and communication systems at higher intensities. The first level is the G1, minor level, where weak power grid fluctuations can occur, and minor impacts on satellite operations are possible. The most enchanting effect, however, is the increased likelihood of auroras near the polar regions, which may be visible at higher latitudes than usual.
Yeah, that link is bad.
To G2, moderate, to G3, strong levels, storms can lead to high latitude power systems being affected, with potential transformer damage. The auroras become more widespread, occasionally visible down to mid-latitude regions. Finally, from G4, severe, to G5, extreme levels, storms are the strongest, which can induce widespread voltage control problems and protective system problems, potentially leading to extended power outages. Auroras may be seen as far south as Florida or southern Europe. These intense storms are rare, but can significantly disrupt modern life. So, the auroras, while beautiful, signify disturbances in the Earth's magnetosphere caused by these solar storms. Several tools and websites offer aurora forecasts and alerts. For example, NOAA provides forecasts about geomagnetic activity, which can help predict when and where auroras might be visible. Additionally, there are apps and websites dedicated to aurora predictions that take into account current solar activity and geomagnetic data to provide real-time or near real-time forecasts. Understanding the varied impacts of these geomagnetic storm levels helps in preparing appropriate responses. For instance, power companies might enhance grid resilience against potential fluctuations and surges during higher storm warnings. Wildlife conservation groups can monitor as well. Also, engineers and scientists have made significant strides in enhancing the resilience of satellites and power grids against solar storms. Looking forward, the integration of artificial intelligence, AI, and machine learning into solar storm prediction models shows great potential for improving forecast accuracy. As a result, we're better equipped to prepare for and mitigate the impact of space weather on our critical infrastructure. As we've explored today, the activity of the sun, while a source of life, also poses significant risks to our modern technological society. Thank you for joining me in this enlightening journey into the power of the sun. Stay curious and stay prepared.
Okay. According to this video from NASA Space News, of course, you know that we've had a major solar storm just a couple of weeks ago, where they knocked out the HF bands for a good while, and nobody could communicate over the HF bands. But our scientists and engineers, fortunately, are coming up with all kinds of ways to protect us from these solar storms. But they give us the worst case scenario. And of course, we know we prepare for the worst and hope for the best. So the sun is this gigantic ball of ionized energy that's always in flux. And here's a picture that I captured from the NASA Space News video that shows the Earth to scale in relation to the sun. And this is just one sunspot that spews out this energy, and the sun has many of those sunspots, but you can see the potential damage to Earth just by looking at that. What is a solar storm? Explosions on the sun basically is what it is. It sends out solar flares and coronal mass ejections, and they can be very strong, and they can send that magnetic energy towards the Earth at a speed of 3 million miles an hour. And the very strong ones can pierce through the magnetic shield of the Earth. This purple line here represents the Earth's magnetic shield, which shields us from the sun's radiation. But when they have these big solar flares and CMEs, it can pierce right through it and cause all kinds of disruptions, which in turn will cause what they call a geomagnetic storm in the Earth's atmosphere. And the geomagnetic storms are disturbances in the magnetic field that are caused by these coronal mass ejections and X-class solar flares. They produce these beautiful, beautiful, beautiful auroras. And when the last, these are taken from the last solar storm that we had just a couple of weeks ago, and people were posting these magnificent pictures all over Facebook. I just couldn't get enough of watching them. There's such a beautiful sight. Mother Nature was doing a dance in the sky. But besides the beauty of the auroras, it also has other impacts to space weather. It impacts the GPS systems. It impacts communications. It impacts the satellites. And the human space exploration astronauts aren't able to go outside of the spaceship during a solar storm because they'd be exposed to radiation. And it'll impact aviation and, of course, our power grids. In space operations, it can throw the uplinks, they call these things the satellites. We got thousands and thousands of satellites floating around out there in space. Some of them are government sponsors, which are doing research, and some of them are commercial, which are beaming down information to us so that we can get our GPS is based on these satellites. Okay, wait, I went too far. Back in 2022, there was a coronal mass ejection that damaged 38 commercial satellites. I believe they were part of Elon Musk's Starlink fleet that were damaged, and they were thrown out of their orbit. This time he said they were under stress, but they held up. Okay, it can also do damage, of course, to the power grid. And like he mentioned, the province of Quebec, Canada, is like twice the size of Texas. And that whole province had lost power due to solar activity back in 1989. And the same thing happened in South Africa and Sweden in 2023. And of course, you know, it can cause radio blackouts. The FM bands are bouncing off the ionosphere, which is affected by the solar activity. I have a link. Excuse me. I have a link to Wave Talkers where they gave information about that. There's several links you'll find in this presentation. I'm not going to open them, but you're free to explore them on your own. And of course, the navigation blackouts. At any given time, there are thousands of planes up in the sky that can rely on navigation system, and they could possibly be knocked off their course. And those navigation systems and the excuse me, I have to drink some water. Yeah, the navigation systems are disrupted. They could possibly run into each other and run off their course. So it's very important that they stay on course and that these things aren't disrupted. like I said, these things are worst case scenarios. They don't happen with every time we get solar flares coming at us, but there's a possibility of this happening. Radiation storms, increased levels of radiation that come out of these solar flares and CMEs, and the solar wind just takes them toward the earth, and the radiation belt. And of course, the only biological effect that happens with these radiation storms is with the astronauts. If they're out in space and they have to stay inside the spaceship, if they go outside, they would be bombarded with these radiation from the sun, and we know that can cause cancer. And so they stay inside when there's a solar activity that's a high level. And satellite operations, of course, it renders them useless, and it can do permanent damage to the solar panels. And I assume they're talking about the solar panels on the satellites, not the ones on your home. And other systems could be blacked out, like the HF radios. So how do we prepare for this kind of a storm? Well, we stay informed. First of all, keep an eye on the space weather. The National Oceanic and Atmospheric Administration, NOAA, keeps us informed. And there's a website, Live NOAA. It's a live stream that shows the aurora forecast and the activity of the sun. You can watch that. And then you can sign up for alerts from NOAA. And there's a Space Weather Live app that you can put on your phone that will let you do it. And of course, there's a place where you can check on the current handband conditions. Also, in preparation, you prepare your home. If you know there's a solar storm and there's activity that's coming toward Earth, you make sure you charge your devices. You prepare just like you would prepare for any other disaster. And you have a backup plan, and have backup power for your home and for your electronic devices, and keep a spare radio, antenna, and batteries in a Faraday container. I have a link here showing you how to make a Faraday cage if you want to do that. And of course, schedule monthly tests to make sure they're usable. You don't just throw something in a Faraday cage and leave it until you absolutely need it, and come to find out it won't be useful. So if you do something like that, make sure you test it regularly. Prepare your family, have us a plan, stock up on supplies, a go bag, and any important documents, family pictures, household inventory on a flash drive. And of course, don't forget cash. And there's another link to preparing for emergencies for further exploration. And your technology, if you know a solar storm is coming, unplug stuff. Unplug your sensitive electronics. Disconnect the antennas from the radios, and things that you absolutely have to keep plugged in, make sure they're plugged into surge protectors. And of course, back up your data, not only in the cloud, because the cloud is just someone else's computer somewhere. So if it affects yours, it could affect theirs too. Anyway, so back it up in the cloud, but also back it up on an external hard drive, and that will keep your data safe. And how do we stay safe during solar storms? Well, like I said, unless you're flying high up in the air or in a spaceship, the radiation won't bother us because we're far enough away from that. But avoid flying during a solar storm. Avoid subway travel, because if the power goes out there, you're stuck in a dark tunnel with a whole bunch of people, and Lord knows what would happen. And credit cards or anything with a magnetic strip can be affected. And of course, stay away from power lines. Any additional trips, just stay calm, because we know that the storms Geomagnetic storms are unpredictable, but they can create damage. But if we know that they're coming and we know what to do, we can just deal with it. And of course, be prepared for these disruptions because you know that there's a possibility that they can happen. And tune into local news if you can. Okay, our last update on May 10th and 11th. That's when we had our recent X-class solar flares, and it was a G5 coronal mass ejection. That was the strength of the Carolyn event of 1859. It was a G5 coronal mass ejection. And it generated these magnificent auroras seen as far south as Florida, but it didn't do an awful lot of damage because fortunately we were better prepared. The governments are all over the world, and our government, the governments all over the world, and commercial companies who have vested interest in these things, they're doing everything they can to protect these equipment that's out there and to protect the infrastructure. But that's not to say that another solar storm couldn't possibly do more damage. And NASA just put out another video today I'm going to play for you. It says it's not over because they're coming back around.
Recent updates have revealed that sunspot AR 3664 is set to face Earth again around June 6th, sparking concerns about potential geomagnetic storms. This reemergence comes after this sunspot recently unleashed a powerful X-class solar flare, causing significant disruptions. In addition, hyperactive sunspot AR 3697 continues to produce intense solar flares. In this video, we will explore the intense solar flares from sunspot regions AR 3697 and AR 3664, their potential effects on our technology and daily lives, and why monitoring solar activity is crucial. Stick around to learn about the latest developments and what they mean for us. Sunspot AR 3697 has captured the attention of scientists and space enthusiasts alike. This sunspot is particularly notable because it's a reemergence of AR 3664, which we discussed in a previous video. AR 3664 was responsible for a significant G5 geomagnetic storm that occurred a few weeks ago, producing some of the most vivid auroras seen in years. Now, as AR 3697, it has returned with renewed intensity. Recently, AR 3697 unleashed a powerful X-class solar flare, peaking at around 10:35 a.m. EDT, causing shortwave radio blackouts across Western Europe and the Eastern United States. These blackouts can disrupt communication systems, affecting aviation, maritime operations, and emergency services. Sunspots like AR 3697 are areas on the sun's surface with intense magnetic activity. These magnetic fields can become twisted and tangled, leading to the release of vast amounts of energy in the form of solar flares. X-class flares are the most powerful category, releasing energy, light, and high-speed particles into space, which can have immediate effects on Earth, especially on communication systems. Currently, AR 3697 is positioned on the eastern edge of the sun's disk. As the sun rotates, this sunspot is moving towards a position where it will directly face Earth. This trajectory is critical because it means that any further activity from this sunspot will have a more direct path to impact our planet. Scientists are closely monitoring its movement and behavior to predict potential future flares and geomagnetic storms. The potential for more X-class flares from AR 3697 is high. Scientists use various instruments and satellites to keep a watchful eye on sunspots, tracking their development and predicting possible eruptions. This continuous monitoring is crucial because it allows for early warnings of solar events that could affect Earth. Such warnings can help mitigate the impacts on communication systems, power grids, and satellites. The data collected from observing this sunspot will help us prepare for immediate impacts and enhance our overall understanding of space weather forecasting. The original sunspot AR 3664, which we previously covered in depth, has once again made headlines with its powerful solar activity. On May 27th, AR 3664 released a Class X2, 8 solar flare, marking one of the most intense solar events in recent years. This event caused significant shortwave radio interruptions, although the coronal mass ejection associated with the eruption did not impact Earth. Nevertheless, the flare itself had substantial immediate effects, demonstrating the potent influence of solar activity on our planet. X-class solar flares are described by NASA as giant explosions on the sun that send energy, light, and high-speed particles into space. The recent X2-8 flare exemplifies this, unleashing a tremendous amount of energy that traveled at the speed of light. When this energy reaches Earth, it can ionize the upper atmosphere, creating a higher density environment for high-frequency shortwave radio signals. This ionization leads to increased collisions between electrons and radio waves, causing signals to degrade or be lost entirely. Comparing this flare to the one from AR 3697, both are X-class flares, indicating their extreme intensity. However, AR 3697's flare caused significant shortwave radio blackouts across many regions, while AR 3664's flare was slightly less intense but still had a substantial impact. The key difference lies in the associated coronal mass ejections. AR 3697's flare did not produce a CME that impacted Earth, while AR 3664's flare did produce a CME, but it was fortunately directed away from Earth, sparing us from further geomagnetic disruptions. A CME is a large expulsion of plasma and magnetic field from the sun's corona. If directed towards Earth, a CME can trigger geomagnetic storms, leading to disruptions in power grids, satellite operations, and navigation systems. In this case, we were fortunate that the CME did not impact us, but the event underscores the potential dangers of such solar eruptions. Looking ahead, there is considerable concern within the scientific community about AR 3664's future activity. This sunspot is expected to face Earth again around June 6th. As it rotates back into view, there is a risk that it could generate another set of geomagnetic storms. These storms have the potential to cause more significant disruptions, making it critical to remain vigilant and prepared. The interaction between solar activity and Earth's magnetic field is a complex and fascinating subject. Recent studies have revealed significant differences in the magnetic field at the North and South Poles, which have profound implications for how solar storms affect our planet. Understanding these differences and their impact is crucial for predicting and mitigating the effects of space weather. Earth's magnetic field acts as a protective shield, deflecting charged particles from the sun and cosmic rays. However, this field is not uniform. It is notably weaker at the poles. This asymmetry means that regions near the poles are more vulnerable to the effects of solar storms. When solar flares and coronal mass ejections strike Earth, the charged particles they release can penetrate deeper into the atmosphere at the poles, causing increased auroral activity and posing risks to technology and health. Recent research has shown that the magnetic field at the North Pole is weakening more rapidly than at the South Pole. This weakening increases the vulnerability of the Northern Hemisphere to cosmic rays and charged particles from solar storms. As a result, areas near the North Pole could experience more frequent and intense geomagnetic storms. Additionally, a weakened magnetic field allows more cosmic rays to reach Earth. Cosmic rays are high-energy particles from outer space that can have harmful effects on both technology and living organisms. The recent intense solar activity from AR 3697 and AR 3664, combined with the variability in Earth's magnetic field, means that certain regions could experience more severe impacts. In practical terms, continuous monitoring of both solar activity and Earth's magnetic field is crucial. Instruments like satellites and ground-based observatories provide valuable data that scientists use to track sunspots, measure solar flares, and assess changes in the magnetic field. In conclusion, the recent activities of sunspot regions AR 3697 and AR 3664 remind us of the dynamic and sometimes unpredictable nature of our sun. These solar events not only create beautiful auroras, but also have significant implications for our technology and daily lives. By staying informed and understanding the science behind these phenomena, we can better prepare for their potential impacts.
Okay, and so that's best to be informed, knowing that these things are coming toward us on Earth, and be prepared for it the best that we can. I have a whole bunch of resources that I've gathered for you to explore at your leisure when you'll receive this presentation, and they can answer your questions a lot better than I can. But that's the end, and I will close it out now and open for discussion.
Okay. That was very good. Thank you, Carolyn. Gene's got his hand up, so take her away, Gene.
Yeah, good evening, everybody. Carolyn, that was a very nice briefing on a very serious subject and situation. Would you say that a solar storm and the various types of products produced by such would be the equivalent of an EMF or EMP that might be produced by the detonation of a nuclear device? Not trying to be morbid here. That's question number one. Number two, are there ways that we as amateur radio operators using our equipment, multimode, multiband types of radios, can observe on frequencies via graphs or software when these changes might be able to be going on, kind of like SDR type of graphs and software like that? Sorry if it's confusing.
Well, you're asking is a solar storm or the X class or the G5 CMEs are equivalent to an EMP? Basically, yes. That's nature's version of the EMP. And we need to be able to shield ourselves from the Earth. It's doing a good job of shielding it with our magnetic shield around us, but we know that it can be pierced by these gigantic solar flares, and the coronal mass ejection. The CME, I believe, would do even more damage than an X-class solar flare. Fortunately, it didn't hit us directly. The solar flares did. It knocked out some power on Earth. But the CME, we missed that, thank God. It was a G5, which is a extreme level CME, but it didn't quite make it to Earth, thank goodness. Okay, someone else can pitch in and try to answer these questions, because like I said, I'm not a scientist. I just gathered, I was fascinated by the sun's activity, recent sun activities, and I started just looking at videos and reading information and put this presentation together because I thought it would be good for discussion.
Yes, and
Okay,
I appreciate you doing that.
Software? I'm sorry.
Go ahead, Gene.
Yeah. Are you aware of any software that could be linked up with a ham radio that could detect these changes in kind of like a graph? You know, just basically monitoring, you know, not transmitting, obviously, but monitoring, kind of like an SDR type of software that you could see spikes on a graph type of situation?
Well, I don't know of any in particular. Maybe one of you guys do, but there are websites that do it. No, Noah manages to the 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 website that has information about solar storms and predictions of when they're going to come, and NASA the same. So there are places that you can go online and get that information, but I don't know of any particular software. But maybe someone else in the room does.
All right, thank you, Carolyn. Again, great job. Thank you very much for that information.
Thank you.
Okay. Okay, Marty, you want to take it?
Hey, good evening, everybody. Thank you, Carolyn. Just a quick comment on the CMEs versus an EMP. The effects can be more devastating, but more localized with an EMP because there are a bunch of different components of an EMP, and the energy in the first few milliseconds is much greater than we would get through a solar activity.
Mhm.
And it's that initial pulse that would do a lot of damage to small electronics. As your presentation showed so well, the stuff that comes from the sun, whether it's just the straight X-ray energy or the plasma material, which takes a lot more time, has it's got the magnetic the magnetosphere around it, so it has to get through that. An EMP would typically be fired off at an altitude that it doesn't really have to get through the magnetosphere. It's underneath the shield, if you will.
Right.
And so there's a lot of good stuff written about that. But ARRL's Dennis Bodson, who's now a Silent Key, he used to be the Roanoke Division director, and he was a really cool guy. He also was kind of an EMP expert for the feds, and he wrote a series of 4 articles in QST back about 25, 30 years ago. You can use the search function to just look for Bodson, Bodson, and you'll find those articles. And of course, you can retrieve them, assuming the ARL's website is back up to snuff, and read them. They're very interesting. And as far as showing solar activity on an amateur radio, one of my friends up north, KB6BA, Oliver, who's a fellow microwaver, did an interesting little experiment with the Owens Valley Radio Observatory trip we made a couple of years ago, and he sat a microwave band, in this case 10 gigahertz radio and a receiver and dish pointed up at the path of the sun, and then we set up a chart recorder to record the level of activity coming, and you could see the curve came out, as the sun came right past the dish and then back down. So yes, you can actually measure with a radio how much is coming from the sun. In fact, a lot of the more sophisticated guys with big directional arrays for moon bounce, they will use sun noise. How many dB of sun noise can they get compared to a cold sky to determine how well their dishes are operating, and their systems are operating, and how accurate their pointing is, and so on. So the sun puts out noise at a lot of different frequencies, and some of those are in the range that we can fairly easily measure it with directional equipment.
All right, thank you for the information. That was very helpful. I'll do some research more into that. Thank you.
All right. Yeah. Thank you, Anthony. Go ahead, Carolyn.
Anyone else have any comments or questions?
Yeah, Steve's got his hand up. Go ahead, Steve.
Okay, several things. One, if you're interested in the natural phenomenon, you want to go to the the NOAA website or NWS website, and they have a tremendous amount of information available. If you're interested in a human being caused EMP devastation, I take you to CISA Central ERO. CISA Central ERO. And that's their job. They have a complete a department that handles what would be the effects of EMP devastation to us first, and then to other things secondly. And that's there's been a lot written about that in that organization. Another thing I put on the map, actual connectivity during the 2 periods that Carolyn mentioned, because when I listen to the weather and they tell me that there's tornadoes and devastation and destruction, and I go outside and the sun is shining and it's beautiful, I question sometimes predictions, but actual facts are facts, and that's actual connectivity on the WinLink system on all the services worldwide. And you can look at you could take a nice day that has no problems whatsoever, high solar flux index, everything's great, and use it as a base mark. Then when you hear these things, you could then read it again and see what the delta is between what you actually are experiencing now as opposed to what you would be experiencing in the future. As far as ham radio goes, I think what we will find is that there may be some deterioration, which is really just a change in frequency for a given distance. I put in there for only $549, you too can have an EMP bag to put your electronic equipment in. That has been, those have been purchased by the Virginia National Guard. They've got 9 of those HF radio stations for Shares WinLink that they put in those bags throughout the state. So there are ways to do it, and I'm certain that I've heard garbage cans, everything from garbage cans to aluminum foil can save the day. But if you go to Amazon, you can find various products that can protect your equipment and yourself. That's it. Thank you.
Thank you.
Okay, well, thank you, Steve. Go ahead, Carolyn.
Steve, that the last part of that CISA Central, that was ELO?
No, just if you go to CISA Central or go to CISA and search for EMP, you'll get a substantial number of articles about that.
Okay, I got you. Thank you very much.
Sure.
Okay, Marty, get your hand up again, and after Marty, we'll go to look at the chat stuff. Go ahead, Marty.
Okay, thanks. Just another quick one. Good information all. Another difference between the say the effects of a CME and an EMP are that because the plasma material does not travel at the speed of light, we have typically 1 to 3 days of warning before it gets here. An EMP, of course, assuming it hasn't been tracked, and you know, it's the whole idea is that it catches you by surprise. You have absolutely zero warning. I mean, in microseconds, the damage starts over the affected area, depending on how what its altitude is when it goes and how strong it is. That determines how far away, you know, how many states and so on it would cover. But you know, so there is no warning on an EMP. There's a lot of warning on the effects of a CME. They even actually have they warn airplane crews because you know, when you get up high enough and, you know, up your, you know, 40, 50,000 feet in an aircraft, you have less protection from solar radiation than you do down on the ground. And so they warn airline crews that are flying all the time in conditions like that. They say they may be absorbing a fair amount of radiation that you wouldn't ordinarily do on the ground.
All right. Well, thank you very much there, Marty. Appreciate that. A lot of good news. Barry, how are we doing in chat?
We're good in chat. I posted a couple of links to Tabitha Scove, who was the space weather woman, and she does an excellent job of showing everyone what's going on with space weather, and someone was asking for software. This company called Solar GIS that has software that we can all download and use to see the different graphs that get generated and stuff like that. But nothing else in chat. And of course, there's a link to the Faraday bag posted by Steve.
Okay, yeah, I saw a lot of information for links and getting material and stuff like that. So you might check your chats, folks, and see if there's something that you might be of value to you there.
And
Any more?
Dave made a good point. There's lots of snake oil out there. Be sure to be careful where you go, what you buy.
Okay, snake oil, stay away from. Okay, any more questions, comments? Carolyn, this is great. I really appreciate you doing this. I hope you do more of these things.
Well, thank you. I had fun putting it together because I learned so much in the process. So thanks, Marty, for that clarification with the EMPs and the CMEs. That's good, very good information to have. And the fact that you're right that there's already within our magnetic sphere, the EMP, would already be within our zone to reach us. At least the things coming from the sun is outside and have a chance of being protected from it. So that's good to know.
Yeah, well, this has been great, and I really appreciate you doing this. Okay, let's put another call out there. Is there any more questions, comments? Well, hearing nothing but crickets, I'm going to have to, I'll call early closure here, say 73s, and get this information all edited up and sent out to Anthony to be put out there on the web, on the YouTube and other sites.